Good day everyone. Today's lesson is all about understanding collisions, rigid bodies, and physics. At the end of this lesson, you will be able to know and learn everything about collisions, rigid bodies, and physics. Know and understand the types of colliders and how they work. Discover the various properties of rigid bodies. Collisions in Unity work as components of a game object, and therefore work independently of the actual sprite and are calculated on their own. The reason for this is that since everything in the game consists of game objects, it would be inefficient for the game engine to calculate the collisions for each game object present in the scene. Now, we will add a simple wall that our player can collide with. To do this, we will create another sprite asset and scale it up using the Rect tool. Then, using the sprite renderer component, we can change its color property to be a shade of red. Let's now add a collider to our wall. From the inspector view, click the Add Component button and type in Box Collider 2D. Click the first component that shows up, and the image on the screen should appear. If you will notice, game objects that have collider components on them will show green lines on the edges of the object. These are called collision boundaries, which are essentially the shape of collisions on game objects. Repeat the same process and add another box collider 2D for our movable game object. Collisions in Unity are not limited to boxes as they can also be various polygonal shapes. Developers and designers typically approximate the collision boundaries to make their games run more efficiently and avoid unnecessary calculations. We will learn how to create different shapes and sizes with our colliders soon. Hit play to see your small game in action. If you notice, the collisions does not seem to work properly. We will solve this problem in the next few slides. The problem lies in the code because we are only modifying the transform component of the game object. Rigid bodies come into play to solve this issue as it allows objects to react to real-time physics such as gravity, mass, drag, and momentum. To add a rigid body component, simply select the game object you want to attach it to, then click on Add Component from the Inspector view and type Rigid Body 2D in the search field. Select the first option that pops up. Now, you will see many different properties in the component, but we will only need to focus on the gravity scale. Set it to 0 so the object will not fall vertically down. Next, we will edit our movement script so that it will move the object using the rigid body component. To do this, we will need to make a few changes to the code as seen in the image on the screen. As you can see, we added another public variable named body. It requires a rigid body 2D which will be used as a reference to determine which object's component will be manipulated. Then, inside the update method, we will use our newly created variable to get its velocity property and continuously update it according to the user input multiplied by our speed variable. In return, the object will move when the user presses on a key and will stop when no keys are pressed, because the input will become 0, which sets the velocity to 0 as well. Save the file and head back to Unity Editor to reload the scripts. As previously mentioned, the public variable we just created requires a reference to a rigid body 2D in the script. This will allow the script to determine which rigid body 2D component should be manipulated. If you hit play without modifying anything, you will get an unassigned reference exception error. This happens because we did not set a reference for it yet. To remove the error, select the game object that contains the movement script. Remember that public variables create modifiable fields in the script, just like what happened with the speed variable. Now, just click and drag the rigid body 2D component to the body field in the movement script. Unity now knows which component it needs to manipulate so the object can start moving. Lastly, adjust the speed variable to somewhere around 5 and click play. The error should be gone now, and the collisions should work properly. We can also do custom collision boundaries in Unity. To do this, find the box collider 2D component in our game object, and click on the icon next to the Edit Collider property. Now, for small green squares will appear on the collider. We'll call them handles and they can be clicked and dragged to adjust the size of the collider boundaries. Right now, we can keep it as it is since it fits our square sprite perfectly. Take note that any colliders in Unity can be edited, not just box colliders. In adding colliders to game objects, Unity will attempt to match the collider's size to the dimensions of the object as it assumes that the boundaries will need to cover the entire sprite. This may work on simple shapes with minimal adjustments required, but not with complex shapes as we will see in the next slide. Unity automatically calculates and generates collision boundaries when you attach a polygon collider 2D in complex shapes. Its auto-calculated shape may not be an exact fit, and that's where editing and resizing the shape takes place. Click on the Edit Collider icon and try experimenting on adjusting the colliders. When you're done, you can click the icon again to exit editing mode. Here are the references for this lesson. Thank you for watching.